Welcome back. This is the final video over nomenclature, and in this course we will learn to name and write formulas for two types of acids. First, we have binary acids, which consist of a hydrogen ion, so H plus is the cation, and then an anion that does not contain oxygen. So a couple of examples would be hydrochloric acid, which is H plus with chloride as the anion. Then we have hydrosulfuric acid, which is H plus again, this time with the sulfide anion, so no oxygen. Then we have oxyacids. They consist of a hydrogen ion and a polyatomic anion containing oxygen this time. Oxyacids are often ternary. So we have sulfuric acid, which is H plus, again with the polyatomic anion sulfate. And then another one would be hypochlorous acid, which would be H plus with the anion hypochlorite. To name binary acids, we start with the word hydro. And then we find out what the anion is. We change the ending of the anion name to ic, and then we add the word acid at the end. We have HCl. We start with the word hydro. And then we determine that Cl is the anion, so that's chloride, and I'm going to change the chloride name to chloric, so hydrochloric, and then I write the word acid at the end. The next one is H2S, so I have S here. That anion name is sulfide, so I will begin with hydro. And then I will change the N to ic, so I have sulfuric, and then acid. Later in the video, we will talk about why it's not sulfic but sulfuric. Oxyacids, we first name the polyatomic ion. If it ends in 8, we change the end of the polyatomic ion name to ic, and then we add acid. So let's do an example. HNO3. The polyatomic ion is NO3, that is nitrate. It ends in 8, so I'm going to change its ending to ic. So it becomes nitric. And then we add the word acid at the end. The next one is H2CO3. I determine what the polyatomic ion is. So it's carbonate. Carbonate ends in 8, obviously. So again, I change its ending to ic, and I have carbonic acid. A useful acronym to remember that the 8 polyatomic ions need to change their ending to ic is over here. I ate something icky. To name an oxyacid where the polyatomic ion ends in ite is the same process, except that this time we are going to change the end of the polyatomic ion name to OUS. So let's see. HNO2, I look for my polyatomic ion, it's NO2. NO2 is nitrite, so I have an ite ending, and I will change that ending to OUS. So we have nitrous, and then I write the word acid again. HClO2, I find the polyatomic ion. ClO2 is chlorite, so I'm going to change that ending to OUS. And this time I'm going to have chlorous acid. You have to write the word acid at the end of all these names. A useful acronym this time is the snake's bite was poisonous. Now let's look at that special note about sulfur and phosphorus. As you know, the ions for sulfur and phosphorus are sulfide and phosphide. Unfortunately, when the anion of an acid contains sulfur or phosphorus, the roots are sulfur and phosphor, not the shorter roots SULF and PHOSPH. So what happens is H2SO4 becomes sulfuric acid and not sulfic acid. Similarly, H2SO3 is sulfurous acid, not sulfurous acid. And finally, H2S is hydrosulfuric acid, not hydrosulfic acid. And for the acids involving phosphorus, H3PO4 is phosphoric acid, not phosphic. H3PO3 is phosphorus acid, not phosphorus. And then H3P is hydrophosphoric acid and not hydrophosphic. So let's practice writing formulas for acids. So first we have to determine the anion, and then we have H plus as the cation bind to the anion. And finally we balance the charges just like we did with ionic compounds. Please note that acids are still classified as covalent even that we balance the charges to write their formulas like ionic compounds. So let's do a few examples. Hydrobromic acid. We have bromic here, so the anion is bromide. What helps us determine that is I have the word hydro in front of bromic. If the anion is bromide, then I have H plus for my cation, and I have Br minus for my anion, and my final formula is HBr because these charges balance already. Hydrosulfuric acid, again, I have the word hydro in front of my acid name. My anion is sulfide. This time I have H plus and I have S2 minus. These charges don't balance. To balance them, I have to multiply the H plus by 2. So for every 2 hydrogens, I have 1 sulfide. Acetic acid, now I don't have the word hydro in front of it. So we have an oxy acid. From the ending ic, I know that my polyatomic ion had to end in A. So my anion is acetate, and the formula is C2H3O2 with a -1 charge. I have H plus with C2H3O2 minus. The charges balance, so it's H C2H3O2 for my final formula. Finally, phosphorus acid. Again, I don't have hydro in front of the name, so I have an oxy acid. It ends in OUS, which means that my polyatomic ion had to end in ite. Therefore, it is phosphite, which is PO3 with a charge of -3. So I balance the charges with H plus and then PO3 3 minus. They don't balance, so I have to multiply the H by 3 to balance it out. And I will have H3PO3 for my final formula. And that's the end of nomenclature. I hope you have taken good notes on this last video. See you in class.